man, the world's gonna run out of natural gas and coal soon. What are we gonna do?
I don't know, it must be back to bicycles and steamboats. Am I right, my guy?
Actually, there's a solution that's been in front of us for a long time.
What is it?
It's the power of water.
AJ, how is the power of water going to help us in any way?
You'll see, kid.
Hydroelectric power is a renewable source of energy which uses the power of water to generate its energy. Nowadays, hydropower supplies just around 20% of the world's energy and about 10% of the energy in the United States. This lags behind coal, nuclear energy, and natural gas, but still creates a very large amount of electricity every year throughout the world. Even though it is not as widely used as the others, hydropower is without a doubt the safest option of producing electricity. Hydropower is the leading source of renewable energy in the world and will be the way to go when our natural gas and or coal supply runs out. Now we're on to the history of hydropower. Humans have been harnessing water to use as power for thousands of years, with some of the earliest examples of hydropower being water wheels used in China, specifically by the Han Dynasty, as the one shown in the picture. A little bit later on, Greeks used these wheels to grind wheat into flour, which was a main staple of their diet as they used this for many of their food products. Some forms of hydropower were as simple as water wheels back then, but through the years they've grown more and more complex and more efficient. Even the earliest hydropower plants were cleaner, more reliable, and more efficient than wasteful and dirty fossil fuel-fired plants and factories of the day. In the 19th century, one really smart person decided to change these machines so that they could create electricity, not so that they could be used to grind up wheat for food. The world's first hydroelectric project was used to light a single lamp, and the first turbine was built in the 19th century. This turbine was developed by a French engineer and was capable of producing around 6 horsepower, not much compared to what they can produce nowadays, but at the time, it was a huge advancement. About 20 years later, engineer James Francis developed a new, more advanced and efficient turbine, and unsurprisingly named it after himself, the Francis turbine. The Francis turbine is still in use today and is one of the most widely used turbines in the world. 1913 was a huge year for turbines, in that the propeller turbine was developed, a much more efficient turbine, and this is the most widespread turbine in use today. As the need for electricity greatly expanded towards the start of the 20th century, the efficiency of coal and natural gas plants increased. Because of the advancements in these plants, this led to these small hydropower plants falling out of power. Now, hydropower was forced to shift to a focus on mega projects, or the creation of huge dams for a massive electricity output. This brings us to the modern-day hydropower turbine, which is a very advanced piece of machinery and shows just how far hydropower has come over the years. This is Kerr Dam in Montana's Flathead Reservation, one of the largest and most efficient hydropower plants in the United States. It's a pretty simple concept, but it takes a lot of technology in order to convert all of this water energy into electricity. It starts out with creating a dam and getting a large pool of water together. This is often done by stopping the downward flow of a river for a period of time, allowing an ample amount of water to gather. Then, when the water is at a high enough level, you open up the dam and allow the water to flow freely down the dam. On the way down, the water passes over a turbine, causing the turbine to spin. When the turbine spins, the kinetic energy of the water is used to power a generator, which converts this energy into electricity for all to use. This entire process is super efficient, and as you can see in the diagram, you need a raised body of water on one side. Then, when the gate is opened, the water from that raised side rushes through the water intake and down the penstock. The flow of the water and its kinetic energy spins the turbine, and as the turbine spins, it powers the generator, which transforms this mechanical energy into electricity. Then, through the transformer, electricity is transmitted to wherever it needs to go. The physics behind this. Throughout the entire process of creating electricity, there's a large amount of physics involved. The main principle of this is going to be Newton's second law, F equals ma, force equals mass times acceleration. As water rushes through the turbines, it holds a very large amount of kinetic energy, which is basically just the energy of motion that an object possesses. The higher the height the water is falling from, and the steeper the incline, the more kinetic energy that the water will have. The potential energy, the energy an object has because of its position of the water, will also become higher. Because energy is not destroyed, this potential energy is converted to kinetic energy as soon as the hatch gate opens. This is shown in the conservation of energy principle, which states that energy cannot be created or destroyed. As the water passes through, its kinetic energy spins the turbine, which in turn powers the generator. The generator is the main part of this process, as it converts this kinetic energy of the water falling through the dam into electrical energy. In order to calculate the power of the water, we focus on two variables. One of these is the flow variable, and the other is the head variable. The flow variable measures volume per unit time and is measured in cubic meters per second, while the head variable is the vertical distance through which the water falls. This is the equation that we use to roughly calculate the electrical energy output. The power equals 5.9 times the flow variable times the head variable. The electricity created is directly proportional to the product of the flow and head variables. As you can see from what was said earlier, the longer the distance and the more water, the more electricity will be created. Another type of hydroelectric power is pumped storage. This form pumps water from a lower elevation to a higher elevation so that they can use it at a later time. It actually requires more electricity to pump the water than the water will provide for the plant in the end, but it is a good resource to have in case there may be an emergency. When using hydropower, there are many advantages and disadvantages. One advantage of hydropower is that it's a very reliable source of energy. There will always be water on the earth, and this makes it easy to continue to create electricity. Except during times of extreme drought, you can always count on hydropower for electricity. Another advantage is that these plants do not emit any of the pollutants that other forms of energy do, such as fossil fuels. These fossil fuels emit harmful gases, such as carbon dioxide. Hydropower doesn't contribute to harming the environment like many of these other traditional methods of creating electricity. Yet, for the numerous advantages, there are also many disadvantages, with the most obvious one being that building these huge dams requires large amounts of land. When damming up water, these companies are killing ecosystems of wildlife and disrupting the natural balance that they have. An example of this is fish not being able to swim upstream to their breeding grounds, where they always return to lay their eggs. Another disadvantage that has recently surfaced is the thought that submerging large areas of land also contributes to greenhouse gases to the atmosphere. A few recent studies of large reservoirs created behind hydro dams have suggested that decaying vegetation submerged by flooding may give off greenhouse gases that are about the same amount as those from other sources of electricity. If this is true, then these hydropower dams may not be as environmentally friendly as we had earlier thought and could be contributing to global warming just as much as other electricity creating methods. This calls into question some of the larger dams that are currently in place, such as the Three Gorges Dam in China. This is the largest hydropower dam in the world, and even though it produces a ton of clean electricity, there's been much criticism regarding it. Environmentalists and critics are calling this a huge catastrophe for many reasons. This dam has allegedly been triggering landslides, disrupting natural habitats, and even causing less rain in the area. Even though this plant produces a ton of electricity, we cannot be endangering the environment in order to chase economic gain. While hydropower plants once seemed to be a godsend to the problem of our depleting energy sources, it has raised many larger and more pressing questions. Are these hydropower dams really as safe as we thought they were? Are these dams hurting the environment more than they're benefiting us? These questions have raised some legitimate concerns about hydropower, and the definitive answer to this is still unknown. But due to extensive research done by a vast majority of scientists, a clearer view on hydropower dams is coming into focus, and it seems that these are in fact negatively impacting the environment. Although they have always been thought of as clean energy, the perception on hydropower dams is going to be changing very soon.
Thanks for listening to my rant, Joe.
AJ, that was so boring. Like, so boring. I mean, why don't we just use some nuclear energy, nuke someone, and make some energy? I mean, what's the worst that could happen?
Oh my god. I just wasted 10 minutes on you, boy. Sad.